Good evening, dear students. So last class we have discussed the MCQs based on the topic hydrocarbons. Okay. So already we have discussed about hydrocarbons, right? So we were discussing the questions. So few questions we have solved in the previous class, right? So we are going to continue with the same. Okay. So I have taken some more MCQs. So let us start with the MCQs. Okay. So the question is, I hope the screen is visible and I am audible to you all. Okay. Yes. Okay. Fine then. So we will start. Okay. So this is the first question. Number of possible alkynes with formula C5H8 is. So this was a question asked in uh, this what 2015. Okay, so what are the number of possible alkynes with the formula C5H8? Yes, what is alkynes? How we are going to explain this? Alkynes means what? It is a unsaturated compound with triple bond, right? We know in hydrocarbons, okay, we are mainly discussing here about the saturated compounds and unsaturated compound. What is a saturated compound? When you have a single bond, right? When you have a single bond between the carbon atom, then it is called as what? It is called as a saturated, okay, and saturated compound, and they are classified in the, okay, so they are classified as alkanes, okay, when you have carbon-carbon single bond. Then unsaturated. Okay, so in unsaturated, we have what? In unsaturated, either we have a double bond between the carbon-carbon or triple bond between the carbon-carbon. So when you have a double bond, they are called as alkenes. And when you have a triple bond, they are called as the alkyne. So what is the question? What are the number of possible alkynes with C5H8? So what is the possibility? So 1, 2, 3, 4, and 5 carbons are there. So what are the possibilities? Okay. So one possibility I can put like this. Let us see. Okay. So here it will be CH2, CH2, and CH3. Okay, so this is one possibility. Count here. So it will be C5 and H is 3, 4, 5, 6, 7, 8. Okay, so this is one possibility. Second possibility, what I can do? Okay, again, I'll write 5 carbons. I will introduce, so I had introduced here at the first, right? The triple bond I had introduced on the first carbon. Now, second, in the second possible structure, what I'll do, I'll put it on the here on the first carbon, right? Now I'll put it on the second, in between the second and third. Okay, I'll place the your triple bond. Okay, now so put balance the this hydrogen atoms. Okay, so your carbon will have tetravalency, so satisfy the tetravalency. So this is the possible structure. So again, C5 and H 3, 4, 5, 6, 7, 8, right? So this is another. So one more, what I can do is, now if I introduce on the third carbon, again it will be what? It will be the same. Okay, it will repeat as this. So can I make one isomerized compound? Okay, so isomerized compound. So just the change in the carbon atom. So what I will do? So like this. So I'll take one of the carbon as a substitute. Okay. So again, what I'll do? I'll put a triple bond here. Okay, on the first carbon. So now balance. So CH, okay, and CH3. So what are the possibilities here? So here there are three possibilities. Okay, there are three possibilities of alkynes. Okay, with this formula C5H8. Understood. So you have to, they have asked you what is the possibility. Okay, Tejaswini has answered it correct. It is A, option number A. Okay, so they have given you a formula and you have to just, what you have to do, just change the position of the triple bond. Okay, and see how many possible structures are with this formula. You can write the structures. Okay, fine. So answer is A. I hope it is clear. Okay, fine. So let us go for the next one. Replacement of chlorine of chlorobenzene to give phenol requires drastic conditions, but Cl of that is chlorine of 2,4-dinitrochlorobenzene is readily replaced. This is because of, okay. So here, so what is the question here? So replacement of a chlorobenzene. So we'll write the structure of a chlorobenzene first. So benzene and you have a chlorine group. Okay. So the replacement of chlorine of chlorobenzene to give phenol. Okay, to give phenol. So this requires what? This requires a drastic condition. So to change from chlorobenzene to phenol, okay, there is a drastic conditions are used. Okay, so but when we want to convert our that your chlorine of the chlorobenzene, okay, to 2,4-dinitrochlorobenzene. Okay, 2,4-dinitro. So 2,4-dinitro means so 1, 2 position you have dinitro and 4th position you have nitro group. So this is readily replaced. So this can be done easily, they are saying. But this, when you are converting your chlorobenzene to phenol, it requires drastic condition. What may be the reason? Yes, what will be the reason? So when you are converting your chlorobenzene to phenol, it requires drastic conditions. Okay, drastic condition means you have to do little, it is a tedious method. Okay, little difficult method. But when you are converting your chlorobenzene, okay, that is your chlorine, chlorobenzene, and you convert it into dinitro. So this is done easily. Okay, this is done easily. So what is the reason, students? Anybody? Yes, try to answer. Try to answer. You can go through the options. Nitro. Nitro group makes the ring electron rich at ortho and para position. Nitro group withdraws electron from meta position. C. Nitro group donates electrons at meta position. Nitro withdraws electrons from ortho and para position. So first what you have to analyze about the nitro group is that you have to analyze what type of uh, this it is, group it is, whether it is electron withdrawing group or electron donating group. Yes, it is a electron withdrawing group, right? So what it does here, so nitro group, it withdraws the electrons. Okay, it withdraws the electron at ortho and para position. So when you write the resonance structures of nitrobenzene, okay, you can see that the nitro group, okay, so they can easily withdraw the electron, okay, from the carbon which is bearing the chlorine group. Okay, and what it will do, it will make this CCl bond weaker. Okay, so the bond which is present between the carbon and the chlorine, it will try to break the bond. So what it will do, so nitro group, what it will do, it will withdraw the electron from ortho and para position. Okay, so because of this, what will happen? Whatever the chlorine group is there, okay, the bond which is created, that is the carbon Cl bond, it will result into a weak bond. Okay, so it is the option number which D. Option number D is the answer. So why? Because nitro group is a electron withdrawing group. Okay, so it withdraws the electron from the carbon which is bearing the chlorine atom. Okay, so ortho and para position. Okay, it will attack the ortho and para position. So this is the answer. Okay, option number D. Okay, Tejaswini has answered it already. Answer number D. Yes, good. Okay. So this was a question asked in 2016. Okay, let us go for the next one. Electrophile that participates in the nitration of benzene. So when you are attacking, when you are doing the electrophilic substitution on benzene, okay, for doing nitration, okay, which is the nitrating agent we are using? We are using concentrated HNO3 plus concentrated H2SO4. Okay, So which is the electrophile resulted from this? It is the nitronium ion. Okay, it is the nitronium ion. So when your concentrated HNO3 and H2SO4, okay, 2 moles of H2SO4 reacts, what you are going to get? You are going to get a nitronium ion plus HSO4 minus, okay, and hydronium ion. So this is the, so which is the electrophile? Okay, it is the nitronium ion. So nitronium ion, so what will happen? Your electrophile is your nitronium ion. So benzene, as it is nucleophilic, so what it will do? It will attack your electrophile, okay? And what will happen? The this will take place, okay? Nitration of benzene will takes place. So the attack will takes place. So nitronium, okay, NO and H. So what will happen? So the resonance structures, it will result into a resonance structure, okay? And you're going to get what? You're going to get a nitrobenzene. Okay, you're going to get a nitrobenzene. So the electrophile that participates in the nitration of benzene is nitronium ion. Please note the name also, nitronium ion. Okay, don't get confused between NO plus and NO2 plus. It is NO2 plus. Okay, how it is generated? I have written the steps. Concentrated HNO3 plus 2 moles of H2SO4 will give you NO2 plus, that is your nitronium ion, plus 2 HSO4 minus plus hydronium ion. So, okay, so this is the electrophile which is used for nitration of benzene. Yes. Tejaswini and Shiva Shankar has answered. Very good. Okay. I hope it is clear. So all the electrophiles, okay, you have to remember all the electrophiles, which how are they are generated, okay, when we are doing the electrophilic substitution reaction, Friedel-Crafts alkylation, Friedel-Crafts acylation, sulfonation, nitration, okay, and then halogenation, all type of halogenation, bromination, chlorination. So everywhere you have to remember the electrophile. Okay, let us go for the next one. Toluene reacts with halogen in presence of iron, okay, iron 3 chloride, that is ferric chloride, gives ortho and para halo compounds. The reaction is, so what type of reaction it is? So toluene, when it reacts, okay, with halogen, toluene when it reacts with halogen. So toluene when it reacts with a halogen, okay, so let me write it halogen like this. In the presence of what? In the presence of ferric chloride. Okay, in the presence of ferric chloride, it will give you ortho and para substituted. That is your ortho and para substituted. This is your ortho halo compound, and you're going to get a para substituted compound. Yes, can you tell me what type of name this it is? Which type of reaction it is? Free radical addition reaction, electrophilic elimination reaction, nucleophilic substitution reaction, or electrophilic substitution reaction. Yes. What type of reaction it is? It is a free radical reaction. It takes place in what? It takes place in the presence of sunlight. You don't have any this, so it is discarded. Elimination means when you are doing a elimination reaction, there should be some elimination of the product. So there you cannot see when I have written this reaction, there is no such elimination taking place. Then nucleophilic substitution, there is no such nucleophile. Okay. So here we are dealing with what? Electrophilic substitution reaction. Okay. So toluene, when you are doing that is halogenation. Okay. So this is a halogenation, that is electrophilic substitution reaction. Okay. Any halogen, when it reacts in the presence of the ferric chlorides, okay, you are going to get a ortho and para substituted halo compounds. Okay. So Tejaswini and Shiva Shankar. Yes, answer is correct. It is D. Very good. Okay. I hope it is clear. Others are getting it correct. Okay. If you have any doubts, you can ask me. Let us go for the next one. For the preparation of alkanes, okay, aqueous solution of sodium or potassium salt of carboxylic acid is subjected to. So when you want to prepare alkanes, okay, when you want to prepare alkanes, okay, that is your saturated compound, there is a requirement of what? Aqueous solution of sodium or potassium salt of carboxylate acid. So what type of reaction it is, whether it is a hydrogenation, oxidation, electrolysis, or hydrolysis. Yes, when you are preparing alkanes, okay. So you are going to take a aqueous salt of carboxylic acid. What is carboxylic acid? Carboxylic acid is COH. Now they have said what? Sodium or potassium salt. So your hydrogen here, it is replaced by what? You are replaced by sodium or it is replaced by potassium. Okay, so it is 2R, 2R. COO. Okay, so this is your what? Sodium salt of carboxylic acid. This is potassium salt of carboxylic acid. So this, when you react, okay, what you are going to get? I'm going to get a what? Carboxylate ion plus Na plus. Okay, so these are the reaction which is taking place. Okay, so it will, so this is when you subject it for electrolysis. What is electrolysis? You're going to take a carboxylic, what you're going to take when you take the aqueous solution. Okay, so when you take the aqueous solution of the sodium or potassium salt of carboxylic acid, okay, you are going to get what? You're going to get a alkane. Okay, you're going to get a alkane. And this name reaction, it is called as what? It is called as the famous coal-base electrolysis electrolytic reaction. Okay, it is a coal-base electrolytic reaction. Okay, so I hope you have heard about this coal-base electrolytic reaction. In coal-base electrolytic reaction, what happens? Electrolysis means what? Okay, you are taking a solution. Now, here what I have taken? I have taken the potassium salt of carboxylic acid. To this, I am passing the electric current. Okay, I am passing electric current. When I am passing electric current, what will happen? The reaction will take place. So simultaneously, they are at two position, that is at cathode, and there is one more end, that is at anode. So at two end, the reaction is taking place. Okay. Now at cathode, what is happening? We have a carboxylate ion. Okay, that is your sodium carboxylate ion. This sodium carboxylate ion, it will give you what? It will give you a carboxylate ion plus sodium plus. Okay, so sodium cation. Now what is happening? So this reaction is taking place at the anode. Okay, sorry, this is taking place at the anode. This is taking place at what? At anode. At anode, what is happening? Your sodium salt of carboxylate ion, it gives you carboxylate okay, ion and sodium cation. Okay, now what is happening? Now here the electrons. Okay, so here what is there? So your carboxylate ion, this is what? RCOO point. Okay, now you are having a electron, right? You are having a electron. Now when you are having two such carboxylate ion, okay, because you are having 2 moles, so 2 carboxylate ion, what will happen? You are going to get what? You are going to get a alkane, okay, plus 2CO2. So this, okay, so here two unstable free radicals are there. Two unstable free radicals are there. Now these two unstable radicals, what will happen? They will form carbon dioxide, CO2, CO2, and these two are alkyl, okay, alkyl groups, they will form a alkane. So like this, at anode, the reaction takes place. Then at water, what you have? You have an aqueous solution. So at your cathode, your water is there. Okay, so water, what will happen? Whatever the electrons they are released, okay, so it will take the electron. It will accept the electron. Okay, it will take the electron and it will give you what? OH minus plus H. Okay, so again these two free radicals will give you H2. So hydrogen gas is liberated. Okay, hydrogen gas is liberated. So this is a electrolysis reaction. Electrolysis means your current is passed. Okay, electrolysis take place at cathode and anode. The reaction will take place. So at anode, what is happening? At anode, the electrons are given out. Okay, at anode, the electrons are given out, and at cathode the electrons are accepted. So so what is happening? Oxidation and reduction is taking place. Okay, so this is a electrolysis reaction. This is a electrolysis reaction. Okay, Tejaswini has answered it as C. Okay, very good. What is hydrogenation? Hydrogenation means addition of water. So are we adding any water here in the reaction? No. Okay, so this is oxidation means addition of oxygen. Okay, addition of hydrogen. This is addition of oxygen. No. Right. Now hydrolysis means what? Hydrolysis. Your water is split. Okay, water lysis. Okay, so hydrolysis means water is split into OH minus and H plus ion. So like this. Okay, so here also no such reaction. So electrolysis. So it is a coal-based electrolytic reaction taking place. So when you have the sodium or potassium salt of carboxylic acid, what you're going to get? You're going to get the electrolysis. So by electrolytic reaction, you're going to prepare the alkenes. Okay, you're going to prepare the alkenes. Okay. Next question. Identify the following compound which exhibit geometrical isomerism. So which is the compound which exhibit geometrical isomerism? Yes, what is a geometrical isomerism, students? Geometrical isomerism means what? Cis and trans. Okay, you know cis and trans. So in geometrical isomerism, okay, they will exhibit two forms, that is cis and trans form. Okay, so the necessity is what? They should have same number of carbon. This okay, the number of the molecular formula will remain the same. Only the attachment of the groups will be different. Okay, so the attachment of the groups will be so two groups when they are placed on the same side. Okay, on the same side, then they result into cis. When they are on the adjacent side of the double bond, then they are called as trans form. So let me show you. So which of the following? Okay, but2-ene, but1-ene, butane and isobutane. Okay, so if you have but2-ene means 1, 2, 3 and 4. So at a second position, you have a double bond in between the carbon atoms. Okay, so the number of carbon atoms across the double bond is the same. So you can evenly distribute, okay, the atoms. So this is your CH3, this is your CH3, CH3, this is your CH and this is your CH. Okay, so this is your what? 2-ene. If I say but1-ene, so but1-ene means what? CH2, CH. Okay, so but1-ene. Okay, so at one position you have a double bond. Now, when you are doing the geometrical isomerism, okay, so the number of carbon atoms across the double bond is not same, right? So there will be a problem. So such compounds will not exhibit the geometrical isomerism. So this is discarded. Butane. Okay, butane is what? Butane is like this: CH3, CH2, CH2, and CH3. So whenever you are doing, whenever we are observing the geometrical isomerism, the necessity condition is that cis and trans form, okay, geometrical isomerism is exhibited by the compounds having double bond. So here there is a saturated compound, so this is also discarded. Then isobutane, okay, isobutane. So can you form any this year? No. Okay. So here also you cannot form the any geometrical isomerism. So we can do it with first compound. Okay. Now let me write the cis and transform. Let me write the cis and transform of the first. Okay. So all the options are discarded. Okay. We have seen what are the reason why we have discarded those. Okay, so let me see. So CH3. So what I'll do, I'll write the double bond. So carbon and carbon. So across the double bond, the number of carbon atoms are same, right? So can I write? So what did I say? So I have when I have the atoms on the same side. Okay, on the same side of the double bond. So I'll write CH3. I'll write CH3 and I'll write here H. Here I'll write H. So what you can see here, the atoms, okay, are on the same side of the double bond. Then this is called as cis isomer. Okay, it is called as cis isomer. Okay. Then second, when you have, okay, again, the atoms are on the adjacent side of the double bond. The atoms are on the adjacent side of the double bond. Then they are called as what? Trans. Okay, then they are called as trans. Remember this, very important. So you can see the atoms are on the same side. Right, the atoms are on the same side of the double bond. Okay, so it is what called as, it is called as cis. So here you can see, here you can see, right? So these atoms are on the same side. Here it is on the adjacent side of the double bond. Okay, understood? So it is option number A. Option number A is the answer. I hope it is clear. Yes? Okay, Shiva Shankar, Tejaswini and Monisha has answered as A. Very good. Okay, fine. So let us go for the next one. Is it clear up to here? All the questions are clear, whatever we have discussed till now? Dhaneshri, the answer is A. Okay, just now I have explained you. Did you understand why? When because across when if I say but one in, okay, so what will happen? The number of atoms across the double bond is not same, right? The number of atoms across the double bonds are not same. So if you want to do the geometrical isomers, the number of atoms across the double bond should be same. Okay. So there should be evenly distributed atoms across. Okay. Or what you can see, uh, uh, there should be across the double bond only we can see the geometrical isomerism. This is a necessity condition. Okay. Uh, So the conditions is that it should have ABC is equals to CAB like this. Okay, this type of condition it should be, or it can be, but there should be a double bond. Okay, the atoms can be different, no problem. But it should be, this is the condition. Okay, this is the condition. I hope it is clear. Yes? Okay. Let us go for the next one. The reagent X used for the following reaction is. The reagent X used for the following reaction is. So this is a reaction, okay. What we are doing here, we have a alkyne, okay. We have a alkyne. It is converted into a alkene. So what we are doing, we are adding hydrogen. When we are adding hydrogen, it is a hydrogenation reaction. Okay. So which is the reagent? Can you tell me which is the reagent which we can use for hydrogenation reaction, students? Yes, very simple, very easy. Many times we have discussed this. Yes, please tell me. We are adding hydrogen here. Okay, so can you tell me which is the hydrogenating agent used here? So there are four options. Please tell me which is the X. What is the reagent X which can be used here? Okay, Hima has answered as B. Dhanyashri has answered as B. Others? Okay. Hydrogenation means we are adding hydrogen. Okay, Shiva Shankar has also answered as B. Okay, so palladium in the presence of carbon. So this is what you can see the number of the same on the same side of the double bond. The what is there? You are getting what? What type of alkene? It is a cis alkene. Okay, we are doing what? We are doing hydrogenation. But what we have resulted alkene is a cis alkene. So we want cis alkene, then we have to use palladium in the presence of carbon, okay, as a catalyst. So yes, answer is correct. Very good. So when we want, so the necessity condition is that we require a cis alkene. So when we want a cis alkene, we have to use palladium in the presence of carbon. Okay. N-propyl chloride reacts with sodium metal in the presence of dry ether to give you N-propyl chloride. Propyl chloride means 3 carbon. Okay. So N-propyl chloride in the presence of dry ether, and sodium metal, you are going to get what? Yes. What you're going to get? What you are going to get? So I'm going to take, so this is what? It is a Woods reaction. Remember, this is a Woods reaction, very important reaction. Please mark it, very important for board exam also. Okay, for board exam, they'll ask you the name reaction. Explain Woods reaction with an example. Okay, or they may give you or they will give you a reaction and they'll tell you what type of reaction is this. Or they may ask you in such way. Okay, complete the following like this. So can you tell me what is the answer? Okay, let me explain you Woods reaction. So Woods reaction. Okay, so this is a Woods reaction. So in Woods reaction, what we are doing? We are taking alkyl halide. Okay, we are taking alkyl halides. Okay, we are reacting with sodium metal. So we require 2 moles of alkyl halide. We require 2 moles of alkyl halides. Okay, in the presence of dry ether. So dry ether is the solvent which we are using. Okay, so what we are going to do? We are going to do a Woods reaction. So we require what? 2 moles of alkyl halide. So this is a alkyl halide. I'm giving a general reaction. Okay, so this is a general reaction. So this is a general reaction. So what we have taken 2 moles of alkyl halides in the presence of sodium metal. Okay, now what will happen? What will happen? So you're going to get a higher alkane. You're going to get a higher alkane. So you're going to get what? You're going to get higher alkane. Understood? So what is your byproduct? 2NaX. Okay, 2NaX and your R and R will, okay, so you're going to get a alkene. So Woods reaction, very important name reaction. So similarly, we'll do with this propyl. Propyl means 3 carbons. So CH3, CH2, Cl. Okay, plus 2Na sodium. So I require, okay, so we require what? 2 moles. So like this, okay, in the presence of dry ether. Okay, in the presence of dry ether. Can you tell me now? So I'll write you, okay, I'll write, so this is the byproduct which is obtained. So what I'm going to get? 2NaCl. 2NaCl. So what will be the product? CH3, CH2. So just join this. Okay, you're going to get CH2, CH3. So how many carbon atoms? 1, 2, 3, 4. So 4 means it is a butane. So the resulted alkane is a what? It is a 1 carbon extra, right? 1 carbon extra. So this was a propyl. Sorry, propyl. 3 carbon atoms, right? Here it should be a 3 carbon atoms. Just a second, sorry. So CH3, CH2 and CH2. Okay. See, so please write the structure, very important. Okay, propyl means 3 carbon atoms, right? So here you can see 1, 2, 3, 1, 2 and 3. So 3 carbon atoms. So what is the resulted product now? You are going to get CH3, CH2, 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 CH2 and CH3. So what I have got? 1, 2, 3, 4, 5 and 6. So what it is? It is a hexane. Okay. So whatever the product I'm going to get, it is a higher alkane. So what is the answer? It is A. It is A. Is it clear? Hema has answered as A. Is it clear? Woods reaction is clear. Very, very important. For board exam also, it is very important. Woods reaction. So you require a alkyl halide. So when 2 moles of alkyl halide reacted with sodium in the presence of dry ether, you result into a higher alkane. Okay. So this is the product. Okay. So propyl means the number of carbon atoms should 3. N-propyl means the alkyl halide is in a straight chain. Okay. So N-propyl chloride when it reacts with sodium. Okay. So 2 moles again in the presence of dry ether, you get a hexane. You're going to get a hexane. Understood? Is it clear? Very important. Okay. So option number A is the answer. Yes. Okay, fine. Let us go for the next one. The alkyl halides required to prepare. So this is a compound by Wood's reaction R. So which is the alkyl halide? So this is your resulted alkane. Okay, this is your resulted alkane. So they have what they have asked now. They have directly given you the product. Okay, they have asked you the starting alkyl halide. So which is the alkyl halide required? So this. Okay, so this is the alkyl halide required. So which is the alkyl halide required? They have asked 2Na plus Rx. Okay, in the presence of dry ether, you are going to get R and R. So what they have given? They have mentioned you the product. Okay, they have given you product. What is the product? This is the product. They are asking you which is this. Okay, which is the alkyl halide. So what is the name of the product? First, we'll write the name of the product. If you don't understand this, okay, you can write it in your carbon hydrogen form. Okay, so it is CH3, CH, CH3, CH2, CH2, and CH3. Count the number of carbon atoms. 1, 2, 3, 4, and 5. Okay, so it is what? 2-methyl, 2-methyl, 2-methyl pentane. Okay, 2-methyl pentane is the name of the compound. Now to obtain this, okay, so what I have to do? What I have to do at this position? Okay, so in Wood's reaction, okay, so what you are going to get? You have to so the you can see that it is not a symmetrical alkane. Okay, it is not a symmetrical alkane because here there is no methyl group. So one of your reagent, okay, so these are both the alkyl halides are not same. Okay, both the alkyl halides are not same. Okay, so they are unsymmetrical alkyl halides. So if I break the compound here, okay, if I break the compound here, so at this position, okay, so like this will be one compound. If I break this compound here, okay, at this, then another will be CH2, okay, CH2, CH2, and Cl. So again, here one, I can put a one like this. So here, if I break, okay, so I'm breaking the compound from here. So if I break the compound from here, what I'm going to get? Here one compound I'm going to get this CH3. Okay. So this is CH and this is CH3. So at this position, I'm going to introduce one Cl, one alkyl halide. Okay. Then another, what it will be? CH2. So here it will be Cl, CH2 and CH3. So this is what? This is a propyl, okay, propyl chloride. So which is the option? Which is the option here? Which is the alkyl halide, which is required to prepare this particular compound? One is your, so it is option number C, right? So option number C. Okay, so this is a compound. So what I'm doing, I'm breaking here. Okay, at this position, I'm going to break here. So what I'm going to get here? So here one I'm going to introduce one Cl group, and then here I'm going to introduce a Cl group. Okay, so these are the two uh, alkyl halide. So if I react this two alkyl halides in the presence of sodium, I will show you. So if I react this in the presence of sodium, okay, and dry ether, so what I'm going to get? So here, so this, okay, so I'm going to get this. So this is our desired product. So this is a Woods reaction. Yes, option number C. Option number C. Okay, fine. Let us go for the next one. 2-butane is reduced to trans-butene using. So 2-butane is reduced to trans-butene using. So which is a reagent by which we can convert our 2-butane. Okay, butane is what? You have a triple bond. So this is a 2 at second position, you have a triple bond. So this is a 2-butane. Okay. So how you can reduce? Okay, reduce means what? You are introducing hydrogen. Okay, what is reduction? Reduction means addition of hydrogen. Okay, so here we are going to reduce the 2-butane to butene. Okay, at butene, that is your trans position. At this is the trans position. Your CH3 atoms are at adjacent to each other. So this is a trans butene, right? So how we are going to do this? So this name reaction, it is called as bridge reduction. Okay, so this name reaction is called as what? It is called as the bridge reduction. So where we are converting the butane group into a trans. Okay, so specifically the triple bond. Okay, we are doing reduction. Okay, from butane, that is from triple bond to double bond with the trans position. Okay, we require a trans position. That is at the terminal group you have CH3 at the terminal position. Okay, at you can see the methyl groups, they are terminal or they are adjacent to each other. So how you can do this? You can do this in the presence of sodium in liquid ammonia by using sodium in liquid ammonia. Okay, the temperature condition is 196 to 200 Kelvin. So this is a required condition. So if you use this particular temperature and use the reagent, that is sodium in liquid ammonia, you can get the trans-butene. Okay, so option number B. Option number B. Okay. Is it clear? So when we want specifically at transposition, we have to use this bridge reduction. Okay, so in bridge reduction, which is the reagent we are using, that is sodium in liquid ammonia. The temperature condition is 196 to 200 Kelvin. Okay, the resulted, whatever the alkene is there, it will be a trans alkene. Okay, let the starting product be different, but if you use this particular condition, that is bridge reduction of sodium in liquid ammonia, you're going to get a trans alkene. Okay, fine. So let us go for the next question. So you have to, so a reaction is given. Okay, benzene is reacted with excess of chlorine. Okay, 6 moles of chlorine in the presence of anhydrous aluminum chloride. So the condition is dark and cold. So condition is dark and cold. You are going to get X. So you have to identify what is the reaction. So what we are doing, we are taking a benzene ring. Okay, we are taking a benzene. We are reacting with excess of chlorine. So chlorine is taken in excess. The condition is that the reagent, it is used as anhydrous aluminum chloride. Okay, in dark and cold condition. So what we are going to get? 6 chlorine. So you have the axial hydrogens, right? You're going to have your axial hydrogens. So all these axial hydrogens, they are replaced by what? They are replaced by chlorine. They are replaced by what? Chlorine. Okay, they are replaced by chlorine. So this is the product. So what is the name of this product? So this is your product. Okay, so this is a product X, option number A. Option number A. So all the terminal hydrogens, your axial hydrogens are replaced by chlorine. So when you have excess of chlorine, all the terminal hydrogens are replaced by chlorine atom. So option number A is the answer. Okay. Next question. Arrange benzene, N-hexane and ethyne in decreasing order of their acidic behavior. So based on the acidity, okay, you have to arrange your benzene, then N-hexane, hexane, CH3, CH2, CH2. So this is a N-hexane, okay, and ethyne, and your ethyne. Okay, so in decreasing order of their acidity. So when you see the acidity, okay, pK value, so there is a different compounds have their pK value. Okay, so ethyne, particularly ethyne, the pK value is 25. Okay, the pK value is 25. Then for N-hexane, the pK value is 50. And for benzene, the pK value is 43. pK value is 43. For your hexane is 50 and for ethane is 25. So when you see the carbon, hybridization of carbon in each state, so when you see for your ethyne, so carbon is sp hybridized, right? sp hybridized. Here carbon is sp hybridized. So the hybridization of carbon in ethane is what? It is sp hybridized. When you see the hybridization of carbon in N-hexane, okay, it is what? It is sp3. It is sp3. How you can say when you have a, so when you are finding out the hybridization of this carbon, so you can see by just side of that, it is having what? It is bearing the single bond. So when you have single bond attached, so it is sp3. Now when you have a double bond and you're finding the hybridization of this carbon, so it is sp2. And when you have a triple bond, okay, so this hybridization of this carbon is sp. So in ethane, you have sp hybridization. In N-hexane, okay, because you are having single bond, so the hybridization of carbon is sp3. And in benzene, as you have an alternative double bond, okay, so it is a sp2 hybridized. So this is the hybridization of carbon in each state. So what will happen? Because you can see there is different hybridization of carbon in each compound. Okay, so the acidity, what will happen? It will increase. Why the acidity will increase? Because the percentage of S character is more. Okay, the percentage of S character more. So as the percentage of S character is more, as it is increasing, what will happen to the acidity? The acidity also will increase. So you can see that, okay, so this is the okay, so when you are writing the acidic behavior here now, so how you are going to arrange? They have asked to arrange in decreasing order. So first will be your N-hexane, right? First will be your N-hexane. So you arrange it in decreasing order. So first will be your ethyne, and then will be your benzene, and then will be your N-hexane, right? So option number D. Okay. Next question. Peroxide effect is observed with the addition of HBr, but not with the addition of HI to unsymmetrical alkene because. So peroxide effect. So when you see the peroxide effect, it is observed when you are adding HBr and not when you are adding your hydrogen iodide. Okay, so why? Why it is observed with addition of hydrogen bromide and not with the addition of hydrogen iodide when you have an unsymmetrical alkene? So this is with respect to the Markovnikov's rule, right? This is with respect to the Markovnikov rule. So when we see the bond, okay, when you have HI bond and when you have HBr bond. So HI bond is a weaker bond. Okay, it is having a weaker bond than your HBr bond. Okay, so what will happen? The iodine free radicals. Okay, what they will do when you are having a when you are doing a addition reaction across the unsymmetrical alkene using the HI. So whatever the iodide these are there. Okay, iodine are there. It will form the free radicals, and whatever the free radical is formed, okay, they will form iodine molecules. So instead of adding, so what we are doing when we are doing the Markovnikov rule, your negative part will be added to the carbon having less number of hydrogen atoms, and hydrogen will be added to the carbon having more number of hydrogen atom, right? So, but when you are using your HI, okay, because the bond is weaker, the iodine, they will produce the free radicals. So the iodine itself will combine to form iodine molecule. Okay, they will not go and add up, or they will not add. Okay, instead of forming the iodine, adding to the double bond, they will form iodine molecule. Okay, so what is the answer? Your HI bond is a weaker bond than your HBr bond. Okay, so instead of forming the free, so iodine free radical combine, what they will do, because they are a weak bond, they will combine to form a iodine molecule. So option number B is the. Is it clear? Okay. So Markovnikov rule is also very important. Please study the Markovnikov rule. Examples very important. Okay. Whenever you have an unsymmetrical alkene and when you want to do addition, so we are going to use the Markovnikov rule. So instead of HBr, so the question was, instead of HBr, if we use HI, it is not, the addition does not take place. Why? Because the bond is weaker. When the iodine free radicals are formed, what they will do, instead of adding to the double bond, they will combine to give you molecules, iodine molecules. Okay. So option number B is the answer. I hope it is clear. Yes. Okay. Let us go for the next one. Identify A and B in the following reaction. So you have a propene. So this is what? This is a Markovnikov rule. Okay. So one I have reaction with HBr, another I have with HI. So in both the case, they have asked you for the major product. They are asked major product. Now HBr in the presence of benzoyl peroxide means what? It is a anti-Markovnikov rule. Okay. Whenever you have peroxides, you know that whenever you have a peroxides, okay, it will undergo what? It will undergo anti-Markovnikov rule. So these are the options. So go through the options. Okay. Option number A is here. So these are the product for A and B. Then this is your B, C, and D. So you know Markovnikov rule, right? So instead of what so you can directly solve it. Okay, so we will solve it and just tell the answer. So here when we are using HBr in the presence of benzoyl peroxide, so whatever the Markovnikov rule is there, it will follow the reverse, right? So what will happen here? Here the negative part will be added to the carbon having more number of hydrogen, right? So what you are going to get? So CH3, then CH and CH2Br. So negative part will be added to the carbon having more number of hydrogen. Negative part will be added to the carbon having more number of hydrogen, and then hydrogen will be added to the carbon having less number of hydrogen, least hydrogen atom. So this is the first product. Now in the presence of HI, what I'm going to get? So here it will follow what? It will follow the Markovnikov rule because there is no peroxides. So what I'm going to get? CH3. So what will happen? The hydrogen will be added to the carbon having more number of hydrogen atoms. and the iodide will be added to the carbon having least number of hydrogen atoms. So this is the answer. Okay, so this is your A product. They have asked major products, right? So this is the major product in both the conditions. So which is the answer? It is option number D, right? Option number D. Is it understood? So please study the Markovnikov rule also, very, very important. Okay, they may ask you directly or such indirect questions are asked. Okay. I hope all the questions are clear. So this completes our questions on MCQs on the chapter hydrocarbons. I hope so. I have tried to take all type of questions. Okay. I hope you have understood, right? So I have taken most of the questions on the concept. Okay. So you also please, if you have any books, okay, so please solve many questions as much possible. So you can solve from previous questions also, papers also, okay. So it will be a good practice for you. Fine. So any doubts? Any doubts? Yes, any doubts? Any questions? I hope it is clear. Okay, fine. So we have completed the chapter hydrocarbons. So next week, I'm going to start with the next chapter. So thank you. I'll end the session here. Okay, so we'll meet in the next week. Thank you, dear students.
Thank you, ma'am.
Yes, thank you.